substations offer clear advantages over their traditional counterparts and offer substantial advantages for grid control. But first, Arnaud, tell me, what is a virtual substation?
Well, a virtual substation is, if I take an image, would be bringing all the brains of a substation into an IT environment, so into computers, servers, or PCs, where we dissociate all the time-critical functions of protection, control, and metering, bring that from electronic boxes, which are embedded into switchgear, into a set of servers of PCs to run the same intelligence centralized and in an IT environment. So separate the sensors and actuators from the brains. So this is what we call virtual substation, meaning that all the intelligence that we need to run at the edge inside the substation is located in an IT environment, segregated from all the equipment layers, the hardware infrastructure.
So quite different from the traditional substation.
It is indeed, yeah. It's quite a big change in the sense that we centralize intelligence, so we need to bring data which are immediately digitized from the sensors, so that every set of switchgear needs to be able to bring its voltage and current sensing, its IOs in a digital format, for the central brains to be able to make all the computation which is necessary to manage the automation and the protection schemes inside the substation.
Would you say there are very clear advantages with these types of substations? And if you could give us some more information.
Yeah, definitely. I think it's, we need to look at it both from a project execution perspective and design, as well as in the operation. So if we talk about the design, first, the biggest advantage of this segregation between the software and the hardware is that we can standardize a lot the hardware itself, meaning the equipment. So whether it's a piece of medium voltage switchgear or high voltage switchgear, we can standardize them by having systematically all the sensors embedded into them, irrespective of their function, their final function. And so you would have sensors systematically built into the equipment with what we call a merging unit, which is digitizing the analog signals into digital signals and releasing those information in process bus, 61850 base process bus, which is an interoperable protocol to provide sample values of these measurements onto an Ethernet ring, right? So the sensors and the equipment are being in the field, standardized, meaning we can reduce significantly the lead time of equipment because we can build them in advance and just configure at the last minute. So there is no complexity of engineering a low voltage enclosure with all the logic for protection and automation, all the interlocks and so on, meaning that the piece of equipment standardized could even be in stock and pulled from stock. So typically a lead time for a substation would be, for the delivery of the equipment, would be in the 6 to 9 months range. We can halve that quite easily. But even when we have more standard design of substation, we could even pull them from stock in a couple of days. So that's quite disruptive in the lead time to be able to execute on a project. The second one on the project side would be that now we look at the brains itself, so all the production and control and automation system, because it's fully digitized, we can configure it completely offline and irrespective of the flows of the physical equipment. So what that means is that this code, which is virtualized, can run in a simulated environment. So we can create configuration of a full substation control system and test this control system in a simulated environment. So we don't need to build the substation to be able to test the schemes, which is happening today. So when we test that, it can be a parallel stream, and we can do up to 90% of the complete testing of a complete scheme of a substation, irrespective of the construction schedule. Meaning you de-risk a lot the project. You can pull much earlier into the project the execution of the test of the full system configuration, and hence reduce the risk on the project, increase the quality, and secure the lead times for the construction. Right.
I hear you say the words standardization, interoperability, and of course de-risking, which makes perfect sense. Are there any challenges that are hindering the uptake of this technology?
Well, I would say there is a change of habit first, which is coming with it. And that's why I think I would link it maybe first to the third benefit, which would be in operation. And that's maybe the most important, is how much flexibility you can get from such a scheme. If you think about how a current substation is being upgraded and changed, the only way is to have a truck roll to a substation, isolate the equipment because the brains are embedded into high voltage equipment. So from a safety perspective, you have to isolate completely switchgear. So it's taking time, it's creating a risk on the network because you have to isolate that piece of a substation to be able to access to the control logic or the protection logic that you have to change or upgrade. Right, so means a shutdown, this means safety hazard, and it means that you're losing a lot of time and a lot of money in those truck rolls. When we virtualize, we are in a computer which can be remotely accessible. So changing a protection scheme or an automation scheme, which is very important in a world where we want to accelerate the pace of change to accommodate more renewable and more EV resources, which are creating schemes which will constantly need some upgrades of the automation and protection schemes inside substations. You can imagine that now from a central control room or a central point, you can create automation schemes centrally, maybe train them with AI, and then deploy them into the substation from a remote location in a centralized fashion. Plus, the turnaround time to be able to do an upgrade is narrowed down to the, let's say, the change of a PC, right? When you update your office software on your computer, you can prepare the image, switch, takes a couple of minutes. So the interruption time is moving from several days, sometimes weeks for large installations, to minutes. Right? So the pace of change can be accelerated a lot. The cost of change, of upgrading or changing scheme is reduced to a very limited element, and it can be managed centrally.
Final question. Arnaud, are there any specific case studies or examples where you can see this technology really making an impact?
Yes, I think we've been able to do already quite some significant advanced testing of the concept. So we don't have live large substation yet with this concept because we still need enough testing and adoption to happen to go live. But this is planned for the coming year. We've done a significant progress, a significant step working with RTE, which is a French transmission system operator, for which we've done a complete substation that is emulated in one of the testing center. It's like with real, physical elements of measurements and control. And we've been able to demonstrate the reliability and the performance of a virtualized substation. So because we need to obviously to have very stringent production time needs to be in a millisecond time. So we could prove that from a performance standpoint and from a reliability standpoint, it is a totally feasible scheme from a technical standpoint and from a reliability standpoint. So this test has been done with them. So it's a substation which is running a set of 26 different protections between the high voltage side and the medium voltage side. So it's a pretty complex one with the most advanced protection function you have in terms of line differential and distance protection that we could fully virtualize, run in a set of redundant servers. So imagine that you remove 14 meters of protection and control enclosures, right? In the traditional way of doing things, is becoming one rack with a set of 3 servers like a micro data center. Micro data center that would be installed at the substation. So from a sustainability standpoint, footprint, time and cost of construction, wiring you remove because you replace in a high voltage substation more than 3,000 kilometers of cables just by a run of fiber optic loop, redundant, right? So this is massive in terms of change. Yeah.
That does indeed sound impressive. Arnaud, thank you so much for joining us and sharing your insights. And for more insights, be sure to join the Enlit community.